Hello students, welcome back and let us start our topic coordinate geometry. Hope all is well from your side and with our fresh mood let us start our topic coordinate geometry. So students, in our previous class we have studied that to locate the positions of a point on a plane, we require a pair of coordinate axes that we have learned in class 9. I hope you have remembered. The distance of a point from the y-axis is called its, you know what is that? X coordinate or abscissa. Do you remember? Okay, so let me repeat again. The distance of a point from the y-axis is called its x coordinate or abscissa, and the distance of a point from the x-axis is called its y coordinate or ordinate. Okay, and I also told you the coordinates of a point on the x-axis are of the form x0 and of a point on the y-axis are of the form 0y. Do you remember? Now see. Here, first of all, let us recap what we have read earlier. As you have seen that a linear equation in two variables is of the form, do you remember the form? Ax plus by plus c is equals to 0. I hope you have remembered this one. Okay, and AB are not simultaneously 0. When you represent it graphically, gives a straight line, and in chapter 2 we have seen the graph of y is equal to ax square plus bx plus c, where a not equals to 0 is a parabola. In fact, coordinate geometry has been developed as an algebraic tool for studying geometry of figures. This thing you have to remember, that it has been developed as an algebraic tool for studying geometry of figures, and it also helps us to study geometry using algebra and understand algebra with the help of geometry. Because of this, coordinate geometry is widely applied in various fields such as physics, engineering, navigation. This is, let us repeat, that coordinate geometry is widely applied in various fields such as physics, engineering, navigation, seismology and art. Okay, now see students, in this chapter we will learn how to find the distance between the 2 points. Is that okay? What we have to do? We have to learn how to find the distance between the 2 points. Okay, whose coordinates are given. Suppose 1, 2 and 2, 1 like this. So for this distance we have to find. Okay, and here to find the area of the triangle formed by 3 given points, and also we will find the area of a triangle whose 3 given points are given. We will also study how to find the coordinates of the point which divides a line segment joining the 2 given points in the given ratio, and also we will find like this. It is a line segment, suppose AB, and we will see how it is divided. Suppose if it's divide 2 is to 3, so that how we will find this. Okay, so in this we will find the coordinates of the point which divides the line segment joining the 2 given points in a given ratio. Is that okay? Now see here. In this, our first one is distance formula. As we have discussed just now, how we will find the distance between the 2 points. So see students, to find the distance between 2 points, there must be some formula. So just see that how we will find the distance formula. So for finding the distance formula, let us see, suppose, just see the example. Here, suppose a town B is located 36 km east and 15 km north of the town. Then how we will find the distance from these 2 points A and B? To find this, the situation can be represented graphically as shown in the figure. We know how to draw the graph. So here A to B, and it is given east and 36 km east and 15 km north. So to find this, what we will do? We will use our previous formula, that is what? Pythagoras theorem. Pythagoras theorem, we remember na? Hypotenuse square is equals to perpendicular square plus base square. Now suppose, see here, if we can use that formula. We can use the Pythagoras theorem to calculate the distance. Now see. Now, suppose 2 points lie on the x-axis. The 2 points lie on the x-axis. We can find the distance between them. For instance, just we will consider Suppose if we have drawn the graph, we will consider A as 4, 0 and B as 6, 0. Okay, just you see the figure. The points A and B, the points, just see here, the points A and B, okay, lie on the x-axis. So from the figure we can see that OA is equals to 4 units and OB is equals to 6 units. So therefore, the distance of B from A, that is AB, will be how much? OB minus OA. So 6 minus 4 is equals to how much? 2 units. So if 2 points lie on the x-axis, we can easily find the distance between them. Is that clear? See, if 2 points lie on the x-axis, we can easily find the distance between the 2 points, or we can say we can easily find the distance between them. Now suppose we take 2 points lying on the y-axis. We can find the distance between them also if the points 0, 3, C and 0, 8, D, this one. Okay, now see, we will use the same method. So CD will be how much? CD, here is D, CD will be how much? 8 minus 3, that is 5 units. So we can find the distance A from C, since OA 4 units and OC 3 units. So the distance will be how much? AC is equals to 3 square plus 4 square, 9 plus 16, 25, that is 5 units. Similarly, we can find the distance of B from DBD is equals to 10 units. Is that okay? Now see, we will use this pattern to find all the formula. Okay, now if we consider 2 points not lying on the coordinate axis, can we find the distance between them? Yes, we shall use Pythagoras theorem. Let us see an example. In figure 7.3, here, just you see this. Okay, in this figure, here, the 2 points the points 4, 6 and Q6 that lie in the first quadrant. This one. This lie in the first quadrant. After that, how do we use the Pythagoras theorem to find the distance between them? Let us draw PR and QS perpendicular to the x-axis from P and Q respectively. Also draw perpendicular from P on QS to meet QS at T. Then the coordinates of R and S are 4, 0 and 6, 0. So RS is equals to 2 unit, QS is equals to 8 unit, and TS is equals to PR is equals to 6 units. So now see here, we have seen like this. So PQ square is equals to what? PT square plus QT square, 2 square plus 2 square, 8, that is 2 root 2 units. PQ is equals to 2 units. Similarly, we can extend this and we can find the value. So finally, you see, we will use this formula. We will to find the distance between the 2 points we have considered here, x1, y1, x2, y2. We will draw PR and QS perpendicular to the x-axis. And then after calculating, just you see the calculating method, and to find the distance between the 2 points, you can say D or here PQ, x2 minus x1 square plus y2 minus y1 square root under. So since that the distance is always non-negative, so we will take only positive square root. So the distance between the 2 points x1 y1 and x2 y2 is PQ is equals to x2 minus x1 square plus y2 minus y1 square root under. And if it passes through the origin, in particular the distance of a point PXY from the origin, then OP is equals to x square plus y square, because at origin x1 and y1 will be 0. And to find the distance when it does not passes through the origin, we will use the formula D or PQ is equals to root under, you can write x2 minus x1 square plus y2 minus y1 square. So this much for this class, and rest in the next class. In the next class, we will start solving the numericals based on distance formula. Till then, stay safe and stay happy. Have a good day.